Greetings, Ma'am Mikay. We are Stratosphere from BSCS 24. We will be presenting our system and demonstrating the database we created for our system. Our system is a document request and appointment system. Ms. Purgatorio will further explain what exactly our system is about.
What is the system? Our system is called Document Request and Appointment System. This system was developed to make the process of requesting barangay documents more convenient and efficient for residents. Through the system, residents can submit document requests online, choose an available appointment, schedule, and monitor the progress of the request. This reduces the need for multiple visits to the barangay hall and helps save time for both residents and staff. For the barangay staff, the system serves as a tool for managing requests, appointments, and records in a more organized manner by keeping all information in one database. Transactions can be processed more accurately and efficiently. Overall, the system aims to improve the quality of barangay services by making document processing faster, more accessible, and better organized. We chose this system because requesting barangay documents is something that many residents experience. Even though it's a simple process, it can sometimes take a lot of time due to long queues and scheduling conflicts. With our system, we wanted to make the process more convenient and accessible.
Why was this system made? Getting a barangay document can be time-consuming for residents because they need to go to the barangay hall, wait in a long line, and make multiple visits. This system was created to make the process easier by allowing them, the residents, to make request documents, schedule appointments, and monitor their request online, reducing unnecessary trips and waiting time.
Who is it for? Para kanino nga ba ang ginawa naming system? The target users, barangay residents, and they can make request barangay documents online, schedule appointments, track request status, view documents they own with basic details. And the next target is the barangay staff, and they can process documents requests, manage resident records and transactions, maintain the database system.
What does the database store? The database store are resident information store the personal details of residents such as their name, address, and contact information. Document information contain information about the documents available for request and including their names and fees. Staff information keep record of barangay staff who manage and process requests. Document request records or the document requests and submit by residents and their current status. Appointment schedules stores the data and the times of appointment made by residents. And payment transactions keep tracks of payments made for document requests and other services. And issue record maintain a history of documents that have already been released to residents.
For our database design, we recreated 7 main tables that work together to support the document request and appointment system. The first table is the residents table, which stores the personal information of barangay residents such as their name, address, contact number, and other basic details. The second table is the documents table. This contains the different types of barangay documents that residents can request along with their descriptions, fees, and processing times. Next is the staff table, which stores information about barangay personnel who are responsible for processing requests and managing records within the system. Fourth, the request table. The request table records all the document requests submitted by residents. It serves as the central table that connects residents, documents, and staff members involved in the request process. Fifth is the appointment tables. This table stores appointment schedules for residents who need to claim or process their requested documents. Next, the transactions table records payment information including payments amount, payment status, and transaction dates. And finally, the resident documents. This table keeps track of documents that have already been issued to residents. It also records details such as the issuing staff member and document validity or expiration dates when applicable. Together, these seven tables ensure that the system can efficiently store, organize, and manage all information related to document requests, appointments, payments, and issued records.
No. Good day, I'm Aljon Gabriel Lanuso and I will be discussing what our database does for our system. Our project is Barangay Document Request and Appointment System. Then the database plays a very important role in making everything work. And that's start. The database serves as the backbone of the system by storing, managing, and organizing all information related to resident, document, request, appointment, and transaction. It ensures that records are accurate, secure, and easily accessible for both resident and barangay staff, allowing the system to function efficiently. But beyond that, let me explain more deeply what our database actually does for our system. Beyond just storing data, our database also implements several advanced features that make the system smarter and more secure. First, we implement the triggers that automate certain tasks, such as automatically record the date when a request is finalized or when a payment is made, and automatically formatting data before it is saved. This reduces manual work and prevents human error. Second, we create store procedures that simply and standardize common operations, such as submitting a new request and automatically creates its corresponding payment record in a single call. This ensures that the database always stays consistent. Third, we design a mask view that hides sensitive resident information such as address, phone number, and emails for unauthorized user. This protects the privacy of our resident. And finally, we implement role-based access control with 3 roles: admin, staff, and reporter, each with specific privilege. This ensures that our authorized personnel can perform certain actions in the system, adding an extra layer of security. Overall, the database does not just store data. It is actively managed, protects, and automates the flow of information throughout the entire system. That covers what our database does for our system. To summarize, our database is not just a storage system. It is a secure and automated backbone that keeps everything running smoothly.
Now that we know what our system is and the purpose of the database in the system, we'll move on to the demonstration of the database.
Good afternoon, Ms. Mikay. I'm Alexandre N. Bakingking, documenter of Stratosphere Group. and I'm the first person to demonstrate the operation of our system. Before I begin, I would like to introduce our group. We are the Stratosphere group who completed the SQL code on May 25, 2026. Below is a brief description of our system. The database for a Barangay Community System that allows residents to request documents and sets appointments online. We will now proceed to the creation of our database. The first, we created a database using following command: create database and database name, document request underscore and underscore appointments, semicolon. Next, we use the use keyword to select and activate the database we created. Use and database name, document request underscore and underscore appointments, semicolon.
Good day po. I was assigned to demo the creation of table. The first table is a resident table. This stores basic personal information of residents. Key points are resident underscore ID must be primary key, first name, last name, birthday, required fields, phone underscore number must be unique and not null, email optional but must be unique if provided, civil underscore status limited to predefined value using enum, voter underscore status registered or not. As for constraint check underscore address check open parenthesis house underscore num is not null or street is not null. This ensures a resident must be at least a house number or street. Both cannot be null at the same time. Second table is documents table. This stores all type of documents resident can request. Key points: document underscore type must be unique, no duplicate. P uses decimal 5 and 2, which had a maximum of 99.9. Processing underscore days stored as text. Third is the staff table. This stores barangay personnel. Key points are staff underscore status has default value, active ensures tracking of availability, active or inactive or on leave. The fourth is the request table, the core table. This is the most important table because it connects everything, like resident underscore ID link to residents, document underscore ID links to documents, staff underscore ID links to staff, optional can be null. Fifth table is appointment table. This handles claims schedules. Key points: request underscore ID is unique, one request, one appointment only. Appointment underscore slot, morning or afternoon. And the sixth is transactions table. This tracks payment. Key points: one request, one transaction. Unique request underscore ID. Seventh is resident document table or junction table. This is a many to many relationship table. It records which resident received which document, when it was issued, who issued it, or the staff. It prevents duplicate annuance of the same document to the same resident unless you change the sign later. That's all.
Creation of mass view. Create a mass view to hide sensitive data from residence table. Create a view mass residence as select shows residence ID, first name, last name, and data format birth date. And as mass birth date, concat left house num as mass house num and concat left street and as mass street, and insert phone number as mass phone number. So it hides from them. And concat def substring index email and write substring index email and substring index email and civil status, voter status from residents.
Good day, I'm Aljon Gabriel Aluso and I will be discussing our triggers and store procedures. These are advanced database objects that we implemented to automate tasks and simplify operations in our barangay document request and appointment system. Let me start with our triggers. A trigger is a database object that automatically executes a set of actions whenever specific events occur in a table, such as inserting, updating, or deleting a record. In our system, we implemented 3 triggers. Our first trigger is called After Update Request Status. Its purpose is to automatically set the process date whenever a request status is changed to release, reject, or cancel. This means the staff no longer need to manually input the date. The system records it automatically the moment the status is updated. Our second trigger is called After Update Payment Status. It works similarly to the first trigger, but this time it monitors the payment record. Whenever the payment status is changed to paid or waived, the triggers automatically records the payment date. This ensures that every payment has an accurate and automatic timestamp. Our third trigger is called Before Insert Staff Email. This trigger fires before a new staff record is inserted into the database. Its purpose is to automatically convert the email address to lowercase before saving it. This ensures that all emails are stored in a consistent format regardless of how they were typed, whether it uppercase, lowercase, or mixed case. Now, let me discuss our store procedures. A store procedure is a prepared set of SQL statements that can be saved in the database and execute anytime with just a single call. Instead of writing long queries repeatedly, we can simply call the procedure and it will do the work for us. Our first stored procedure is called Get Resident Request. It accepts a resident ID as input and retrieves all requests made by the specific resident, along with the document type, purpose, request date, status, and payment details. This makes it easy for staff to view the complete request history of any residents with just one simple call. Our second store procedure is called Submit Request. This is the most important procedure in our system. When a resident submits a document request, this procedure automatically does 2 things at once. It creates the request records and immediately creates the corresponding payment record with the correct fee. This ensures that every request always has a payment record linked to it, preventing incomplete or missing data in our system. Those are our 3 triggers and 2 store procedures. To summarize, our trigger handle automated tasks in the background without any manual input. while our store procedure simply and standardized common operation. Together, they make our system more efficient, accurate, and reliable. In a moment, I will proceed the demonstration how each of these work in our actual database. Thank you.
Residents. The first insert statement adds 3 sample residents into the resident table. It includes their personal information such as name, birth date, address, phone number, email, civil status, and voter status. Notice that first resident has a null email value, which means no email was provided. Documents. This insert statement adds sample documents that resident can request. Each record contains the document type, description, fee, and estimated processing time. Staff. This section inserts staff record into staff table. One example is Anna's email, which is written in uppercase letters. When this record is inserted, the email trigger is activated and automatically applies the formatting or validation rules defined in the database. Request. This insert statement creates sample document requests made by residents. It records which resident submitted the request, the requested document, the assigned staff member, the purpose, request date, and current status. Stored procedure. Next, the submitted request stored procedure is executed. This procedure simplifies the process of creating a new request by automatically performing the required operation instead of manually inserting all the related data. Appointments. This section inserts appointment records linked to request. It includes the appointment date, time slot, and appointment status. Transactions. This insert statement records payment transaction for document request. It stores the payment amount, payment status, and payment date. Resident documents. The final insert statement records documents that have already been issued to residents. It includes the resident document issued, the staff member who issued it, the issue date, and the expiration date. For capitalized status values, this field uses the enum data type. Enum automatically accepts and stores values based on the predefined list as long as spelling matches the allowed options. The database ensures consistency in the stored status values. For triggers, when a record is inserted or updated, the corresponding trigger is automatically executed. The trigger handles validation or formatting rules without requiring additional manual actions from the user.
In the role creation and privilege assignment, rules and privilege assignments are created to ensure security, control access to data, simplify administration, protect the integrity, and ensure user can perform only the tasks relevant to their responsibilities. We create rule, admin, staff, and reporter. Admin rule. Have full access to all tables and operations. Grant all privilege on document request and appointments to admin. Next is staff rule. Can view, add, updates, and remove records across all tables. Grant select, insert, update, delete on document request and appointments to staff. The next is reporter rule. Can only view records. Is ideal for personnel who only need to generate reports without modifying any data.
Grant and revoke privileges for reporter role. Reporter role read-only access to mask resident view to protect sensitive data. Grant select on document request and appointment mask residents to reporter. Reporter role can view requests for reporting monitoring purposes, and grant select on documents request and appointment request to report. And reporter role can view transaction records for grant select on document request and appointment transactions to reporter. Reporter role can grant up select and update on residence document and first before revoking, and grant select update on documents and appointment residence documents to reporter, and explicitly revoke update capability from reporter to enforce read-only policy. Revoke update on documents and requests and appointments residence documents from reporter.
Now we move on to our select and join queries. We'll head to our more simple queries. So first, we are going to use the get resident request. This is actually a procedure which we will see again later on. We call the procedure to view the requests a resident may have made in the past or current requests they may have. We use the resident's ID as the argument to specify which resident we want to view the records of. Now we move on to the next query. This one is actually not too simple, but it is still easy to understand. This query is used to view the detailed records of all requests and transactions. Concat is a string function, and we are using it to basically merge two attributes together into one column. Here, resident first and last name attributes were merged together in basically a temporary attribute called resident_name, which will display the resident's full name together. The rest of the attributes to be displayed with their respective aliases, which defines the specific table the attribute displayed will be from, is stated before defining the tables that will be accessed. The attributes from the table requests will be joined together with the table residents, documents, and transactions. The alias for each table is defined here. There is also the join predicate, which is the part after the on is used to specify how to match the rows for each table. For example, the resident ID from the request table will be matched with the resident ID from the resident table. This ensures that the record with unique resident IDs from resident table will match with the same IDs referenced in the request table. The result is that the resident name that will be displayed will be the resident with the same resident ID referenced in the request table. The same principle goes for the rest of the join predicates, making sure that the records and information that will be displayed will correspond with the correct request record. Next query. This is used to display a scheduled appointment, its time slot, along with the full name of the resident who made the appointment. Concat is used once again to display the resident's full name in one column. The main table we'll be taking the data from is the residence table, joined by requests and appointments. The requests table serves as like an invisible bridge between residents and appointments in this query. The appointments records need to match each corresponding resident, which it cannot do directly. Each appointment corresponds to one request, who then corresponds to the respective resident. So basically, the request table is used to match which resident and appointment go together. Oh, speaking of which, the join statement used here is inner join. Using just join without any specific identifier defaults to an inner join. Now we move on. This is a very simple query. It counts how many requests are under each request status. We just want to know the total of request status. So we declare that attribute, then just wanted the total number of rows, we could just use count and with an open close parenthesis and an asterisk on its own and what table to count. However, we want to know how many rows per request status. That's why we use group by. Count with an open close parenthesis asterisk with group by will count how many rows has each perspective status. If 2 records has released status, then the count function will output 2. We can technically remove the declaration to display the name of the request status, but that will leave us with just the totals with no indication what status the number counted is for. So we just declare the attribute being counted so that there will be a clear indication. The next query is used to update and view the request table. Very simple. Use the keyword update on the table you'd like to update. Use the set clause to specify what attribute you want to make a change in and the value you want to change it to. Then use the where clause to specify which record or records you want this change to be made. Without this, the whole column will be changed. Use the select clause with an asterisk, and then from clause to view all the records and attributes of the table you want to view. This update of ours actually triggers, one of our triggers. When a request status has been set to released, rejected, or cancelled, the process date will be automatically filled out with the date of when the status was updated. This query works pretty much the same as the previous query and triggers a similar trigger as the last one. Once the payment status in the transactions table is updated to paid or waived, the trigger will be triggered and the payment date will automatically be filled out. Then view the transactions table to see and check the new changes. Now we'll be moving on to our more complex queries. So this query still basically runs with the same logic as the previous queries we've discussed before, so I won't go into extreme detail. So this query allows the user to take users with pending requests and view the full request details along with its corresponding transaction record, excluding the payment date. The join statements allow each table to be gathered together and be accessed. The columns are specified to specify which columns of data are to be displayed. The where clause then specifies which records specifically are to be displayed. On to the next query. So once again, same thing as the previous query, but this query is for viewing appointments in full detail. This query wants all appointment records to be shown, so the where clause was not used. However, this query uses the order by clause instead. This sorts the data by appointment date. As you can see, the data shown are sorted by date in ascending order. Next query. So this query is a subquery which will return residents who has never made a request before. First, we specify the columns we want to display. We want to view a resident record, so we get this data from the residents table. Then we specify which record specifically we want to view, which are the residents who has not made a request before. Our subquery will select all the resident IDs referenced in the requests table, which indicates the residents who made a request before or currently made a request. The distinct modifier removes duplicate values, so we are left with only unique ones. Basically, all records that are duplicates will be removed. Again, our subquery gets all resident IDs in requests table, and the not in operator basically says to our main query, don't include the residents whose IDs are found in the subquery. Our main query then returns the records of the resident whose ID is not found in the request table. This next query can be a bit tricky at first look. This query counts the total number of requests that have been made for each document that has been requested and the amount collected per document type. It also shows how many requests fall under each payment status. The data is grouped together by document type and in descending order by the total of requests made. This makes it so that the data that will be displayed won't be just one record showing totals and sums, but it will be grouped by document type respectively. The count functions count how many records requested each document type and how many of those said requests has been paid, unpaid, or waived. When the record matches the case statements, one count will be added. The sum function basically adds the values of the records with the paid payment status. This shows the total amount of money collected from payments. The sum function also uses a case statement to check if a record has paid as the payment status. If that is true, then the payment amounts columns values will be added together. And also, left join is used for this query to access all records from the document table, including those that may be null. However, we can see we don't have a null value for this table. So, on to our last complex query. So, this query works basically the same as the previous one. Because of the left join, all records from staff will be shown, including if there are null values. In this case, we don't have any null values similar to the previous table in our last query. All staff are displayed with their full name, their status, the total requests each staff handled, the total amount of money they collected through those requests, and the total of documents they have released. This grouping was made possible once again due to the group by clause, which groups by staff ID, staff's first and last name, and staff status.
Now, we will discuss our transaction management implementation using the ACID properties of the database. ACID stands for atomicity, consistency, isolation, and durability. These properties help ensure that database transactions are reliable, accurate, and secure, especially when multiple operations are performed at the same time. In our Barangay Community System, we demonstrated ACID through a transaction that handles the cancellation of a document request. Before executing the transaction, we first retrieve and display the current records from the request, appointments, and transaction tables. This allows us to verify the existing status of the request, appointment, and payment information before any changes are made. Next, we begin the transaction using the start transaction command. Inside this transaction, we perform three related operations. The first step is updating the request status to cancel. This indicates that the resident no longer wishes to proceed with the document request. The second step is uploading the associated appointment record. Since the request has been cancelled, the scheduled appointment must also be cancelled to keep the data consistent. The third step is updating the payment record by changing its status to waived. This ensures that the resident will not be charged for a request that was cancelled. These three updates are grouped together into a single transaction. This demonstrates atomicity because all operations must succeed together. If one operation fails, the transaction can be rolled back, preventing partial updates and maintaining data integrity. After all updates are completed successfully, we use the commit command to permanently save the changes to the database. This demonstrates durability, as the changes will remain stored even if the system is restarted. Finally, we retrieve the records again from the request, appointments, and transactions tables to verify that all statuses have been updated correctly. This demonstrates consistency by ensuring that all related data remains synchronized and accurate after the transaction is completed. Through this implementation, our system demonstrates the practical application of ACID properties, helping maintain reliable and consistent database operations.